How's it going, everyone? Welcome, Eulier Gonzalez here. And well, yes, we still don't have any lights here. However, I hope now the handyman will come, I don't know, maybe the next week or in between 2 next weeks or 3, who knows. But in today's video, I'm going to now dive deep quickly on this topic now, which is the numbers and the number behavior. And why we're looking at this? Well, I don't want to do a huge intro that we have done before in previous videos. I want to be very consistent, very persist, so we can now jump into what we really care, right? Which is understanding now the primitive, especially the string, to make a quick recap of the string as well as the number and its behavior, so we can then look up to the other primitive, and we can now finally wrap up this course, so we can after this move on to the second pillar of JavaScript, according to Kyle Simpson. But in any case, the idea of this is that we now, by looking at the language per se, and as a way for us to look at the areas in which we need to focus our attention, or we need to dominate, all right, which is the synchronous nature as well as the asynchronous, and how now on the asynchronous nature, in other previous videos we went a quick recap to understand now the callbacks as well as thongs, the promise, how you can work with promise, chaining promise or tenable promise, generators, iterators, so you can create now your own asynchronous way with that. And now some advanced pattern when it comes to handle concurrency in our applications, like the how do I put it, observables, when you want us to deal with this series of eventual values, and something that now language like Go actually use, which is this communication sequential processes. All right, again, this is now in the realm of the asynchronous nature. All right, and now when we look at the synchronous nature, which is what we really care in today's video, all right, the three pillars is now the type systems, which is the primitive, all right, as well as the so the primitive, the abstract operations, as well as the equality, and also the type system. Again, this is to summarize to what is relevant for us, and also we can now understand by looking at the spec how the language is working and is doing behind the scenes. Now, so this is JavaScript, right? The first pillar of JavaScript, the type system. Then we are going to look later at the scope system, all right, and then now at the object oriented system. So this is great, this is good, because, all right, by exploring at the first pillar, all right, which is the type, like this, okay, yeah, like types here, but I just want to show you is this core overview, exactly. So the type, which is the primitives, the abstract operations, we're going to know what these abstract operations means, the coercion and the equality, okay, and the TypeScript and flow, and just a quick recap of this. As I mentioned before, the scope, the nested scope, hosting closures models, so we can now understand is how all of this actually builds together to now understand is the model pattern. And then now the object, which is the this, the class, the prototype, and OO versus OLOO. All right. So far so good, right? Because now, with this, we first look at the primitive type. In previous videos, we also now went through all of this, specifically the primitive type, the abstract operation, the coercion, and the equality. But we went over the primitive types as a way to now understand is the entire model in itself, right? The type system. But now we're going to now dive deep into the primitive type, which is something that we really need to know, and it is crucial for us, especially if you're going to work for any particular application, let's say in the finance or gaming, or fintech, or building a landing page for a studio, you know. Well, here is the type, the primitive. So first we look at now the primitive type, which is the undefined null, known as the nullish values, as well as the boolean, symbol, big int, string, and number, right? Then another, which is not a primitive, is another data structure known as objects. So first we'll look at what is this nullish values, right? Which is undefined, null. What are the operators for that? What they represent? What means null and undefined? And also is how you can use some of the recent operators from the EX6, okay? And that is the conditional coalition, all right, which is nullish coalition. So for example, like this, and how this is not encouraged to go with or to use this, because it can introduce some, especially when reading the code, it can introduce you some confusion. But at the end of the day, this what it means is to say, hey, I'm going to check if the property on the left is on exists before property access. So for example, here we look at this example. So here is telling this, check the record for null value before accessing to the shipping address, right? And if it's not, it's gonna throw now a null error, okay? So you take a look at this, especially at the nullish collision. It is the nullish, the conditional, nullish. No, the conditional nullish, optional chaining, as they call it. Okay, they call this optional chaining. All right. Nullish conditional chain or optional chaining. Or optional chaining. I don't know why it put that. Oh my god, for real? Okay, or optional chaining. Alright, or optional chaining. Good. There you got it, so optional chaining. And here we are. Yep. Optional chaining. And then you get right. The operator ops it calls or calls a function if the object access of the function using this operator is undefined or null. The expression shortcuts and evaluate to undefined instead of throwing an error, right? So if this doesn't exist, it will throw you as an undefined value. So again, you might find that this can be quite useful or not. For those who are not familiar with, well, what it's gonna do is to throw undefined if this doesn't exist. But again, it doesn't improve the readability of your code. So the TLDR of this is that you need to, this is for when you're not sure that this data type exists. And especially if you have now a lot of data type without knowing, all right? Because this also works not only for property, but also for function calls, all right? Some non-existing method, all right? And I want you to call that. The optional changing is preferred to use now TypeScript guard here, or if conditions, so guard here. So in any case, all right? We also look at the knowledge collision, which is useful for set of default value, especially for if you're working with React or even Vue, that will help you to set up a default value when the component load without loading any parameters. And I think that's beautiful. That's beautiful. The other is distinguish. Here, there is something that this knowledge collision actually might help you to do that. Because this distinction, especially if you are going to set default parameter values like this, okay? And therefore, well, you put now the default value parameter here as hello, all right? The default parameter here as hello. Why? Come on. For real? Oh my God. Jesus fucking Christ. This wants to go up. This wants to go up. Exactly. So for example here, okay, if you for some reason now you got this, and therefore you want to, for some reason, if you use now this default values, this optional, this default value, parameter default values, and it's called parameter default value because parameter is when you refers a variable inside of a function. An argument is something that is a value that you pass to the function, all right? So in our case, when you do that, and if you for some reason now pass null, unfortunately that will get rendered. So how you can prevent that particular behavior with the distinction null? Well, glad you asked. By actually using the knowledge collision, so you can make sure that even that you pass now is the default values as or this knowledge value like null. Well, you're going to get now set up that you make sure that you have that preset for that. So this is one. The other, all right, is this. Is say, okay, so what is the another primitive? We have now the booleans. So there is nothing too much to discuss here. You just true or false, right? And when you use the negate, you just want to flip over a value. But now we look at one a universe open up here with strings similar with numbers that I don't know that a lot of developers know how that things actually works per se. And I want to is first describe is the string value as well as the behavior, and the same for numbers, values, and the numbers behaviors. All right. So with the string value, we already know how to set that up using double quotes or single quotes. Okay. But if you think that you have heard about that UTF-8 or 16 and that's all that you need to know, you're not even close to the reality, which is that JavaScript use now Unicode, which is this umbrella terms for representing a variety of character set. That one of them is USC2. The most common is the UTF-16, which is quite the same but not the same. All right. But the point of this is that this Unicode, this character encoding representation, which is way much bigger than the ASCII, which uses 7 bits to represent English characters, right? This is one of the reasons why you, for example, cannot use is in your domains the letter ñ. This is for Spanish, right? However, you can use that, all right, in as a DNS. You can use that using now a specific character encoding code called is how it is called, Punicode. Exactly, Punicode. So, but in any case, what does Punicode is to now serve as a gap between the ASCII and the Unicode, and now reuse some Unicode, some ASCII characters, and they map them to the Unicode, right? So, but what is this Unicode? Well, there's 16-bit representation of all the possible characters that now a computer can represent, that go from 0 to 655305, which this character set are represent or is known as the basic multilingual plan, right? So we can actually look at that if you use a code, and if you want, for example, now have access to one of these character lengths, you can use that by accessing through the string static method. You can type string and you say dot from char code point. You now type is the number of that, and then it's going to give you is what that number is mapping to, which is great, because with this notion, all right, any character that goes beyond that 65535, okay, it now sits in the realm of the astral plane. And I really love about that name, because when I started to understand what this means, I didn't quite get what that astral plane is, but as you can see, this is a way to represent is this beautiful landscape that happens beyond our borders, right? It's like what's happening beyond the earth, we don't care, the astral plane, right? So if you want to represent now characters beyond the basic multilingual plan, beyond the earth, all right, well, it is used now these two 16-bit known as surrogate pairs, okay, or adjacent pairs. The reality is that it's using 21-bit, but it's 16. Okay, we can think of this. That these surrogate pairs allow us to describe now as elements like a poo emoji. Okay, so that poo emoji which their number, let me actually put it here, enough. Oh my god. You got it. So for example, the poo emoji, we can represent the poo emoji, which the Unicode, which is these special characters of the string, all right, and then we can pass now curly braces. Why is this? Because by default now Unicode, what it does is to because Unicode initially can be represented as 4 characters, all right. Perhaps some of them are not gonna render, okay. But some characters, okay. Anything that goes beyond that is just not going to represent that, because the Unicode format is this U followed by a 4 or 6 hexadecimal, and to prevent that behavior, all right, well, we wrap that into a curly braces. Okay, so as a way to represent now the poop emoji, all right, which is the 1F4A9, and as you can see, so 1F4A9, all right. That's quite interesting. And as you can see, when I ask about the length of this, it tells me that this is 2. So here's when things get tricky, because the way how now these characters by JavaScript is interpreted is via this surrogate pair that I mentioned. Since we're using now Unicode, in any 16-bit it means like 1 length, all right. So it is quite hard to actually try to represent is the length of an element, especially the length of a character, that grapheme, visually to a string of characters, right? So this is one of the reasons why this poop emoji, it has now the length of 2, because now it belongs way beyond the abstract plane. And if we want to know, for example, what is the composition of this, all right, we can now split this, all right. So it's gonna give us is this 2 character or 2 16 bits that is made of, right? So this is great, and if we read about this code, right, if we use this code here and we say, hey, can we use this individually? No, it doesn't work, all right, because they are now called surrogate pair, because they actually needs to be adjacent to each other, or in this case, this composition of Unicode must be adjacent to each other, so they have now meaning when to map that particular character. So in other words, we have something like this. If we combine this like so, then we got now our poo emoji. And not to mention that with this, we can also create now compositions of emojis, right? Or for example, the family, right? Where now the family here say that is 11. So you might wonder what the French toast is happening here. Well, the thing here is that this is now a composition of all of this Unicode that is made a surrogate pair, all right? That now, when you combine those surrogate codes, or known as graphemes, when you combine all of those symbols, you actually can create this particular elements, right? Especially on this one. So for example, you do something like this. There you got it. So you can see now what is the composition of these graphenes, right? So it is made of two women, followed by a white space, and another white space, and followed by two males with a white space, right? So this is important to understand, all right? Because when we're starting to look now at the behaviors of a string, all right, such as how you can have access to a character via now the curly braces. We're not gonna dive deep too much into that. How you can now iterate through characters. Well, using now the new AX6, you can use that with this for of loop syntax, which what it does is to say, hey, this particularly primitive object, okay, node string, it has now internally some custom hooks known as symbol hooks, or symbol known as well-known symbol. That these well-known symbols is something that you can see here. For example, if you take a look now, this symbol here, the symbol here. Ooh, I missed that. So for example, like the symbol here. So this known well symbols, again, using that symbols and symbol behind the scene, we're gonna see that later a little bit, that but symbols at the end of the day is a primitive that allow you can think of symbols as a counter that now internally is being taken care of by the engine, but you can't have access to that value. So here we're using is now this ability of the symbols to allow us to access to those particular properties that when we need to, for example, access to a specific custom hooks. So for example, in the case of the string, let me put it now string here. Let me pull up string here, that's right. So for example, here in the string, we have now this thing, this custom interesting thing method, which is string property, something that we're gonna see that later on, is now an internal method that is the behavior of how we're going to iterate through these collections, right? So you can actually have access to that, get that, and since this symbol iterator is this iterator is describing is the way of how we're going to iterate through that collections, defining a contract here, and that contract, which is just a fancy way to say that this is an object, all right, that have some properties and methods. So this contract here, now we can have access to that, and using this special method called .next, we can actually iterate through that element manually. All right, we can think of this iterator, all right, like if we have now full control of turn on and turn off, like if we have full control of what are the things that what are the steps that we want to do when we want to organize a party. Okay, we already have everything there, and then only us are capable to decide what are the next step to do or to execute that. But in any case, I don't want to go far with that analogy. The point of this is that with this next iterator, or with this iterator, it exposes us now a contract that has some internal methods. One of them is next, that say, hey, you know what? Let's go into now is iterate or call that next element and next element and next element and next element. So we can do that whether it's using is a while, all right, which is a particular property that it has to, or a for loop, and then magically, this is not magically, we can get each one of those characters at that string. Okay, we described now two behaviors. First is how you can have access to this, how you cannot mutate is the string, like if you have access into that. Also the way of how you can iterate through that, the character iteration, the length computation, which to me is important. And this is now when you need to normalize that, all right, especially when you somehow, for example, have these particular words in Spanish, okay? It is important that any time that you're going to do any sort or compare or length computation analysis or length analysis, it is important to normalize that, because now once you do that, all right, you can actually compare or sort those numbers in an expected way. Now, because of this, there is now an API called the Internationalization API, which is most of the time something that has a lot of time out there. This Internationalization API, what it does is to say, hey, let's go to provide now you a alphabet that you can describe using the collator, right? So when you need to, for example, compare compare two words, all right, alphabetically, let's say in Spanish, in Greek, in Chinese, all right, or in English, if you want to compare those two words in that particular language, if one of them comes after the other, we can use now the collator compare to do that, which is great. The other is the segmenter. If you want, for example, now to iterate through a sequence of how do you put it? Through a sequence of Jesus. Through a sequence of strings, right, or words in that string. So we can now is using the segmenter get all of these particularly words or characters, regardless the language, all right, which is great. For example, if you want to do some text analysis, right, so you want to extract that and then now put it onto some sort of LLM, yada yada yada, and then you want to do now text analysis based on that. You want to convert it into an embedding, so on and so forth. So that's great, that's good. So the other now, as I mentioned here, when dealing with the Unicode, it's important to that internationalization. I also made some demos to look at that, all right. That might be another very interesting questions to go with. So another behavior is a string concatenations and a string comparison. And the string concatenation is that, well, anytime that you wants to use now a plus, if one of those operand is a string, is going to perform now a string concatenation, and the other is a string comparison. Again, we're going to see that later on the abstract operation, but the string comparison is that take a look at the double equal, the triple equal, the object.is, that at the end of the day, each one of those follows a predictable algorithm that it sits on the ECMAScript spec, and it is quite again, it is a well-defined algorithm, so it's not some sort of magic that happened here. And we can now, for example, in this case, all right, in this case, we can now predict what will be the output here. All right. So we can now predict what will be the output despite that it says true. We can describe what this algorithm is going to do, which is any time that it's going to evaluate Boolean values. First, we're going to evaluate here. So when it's going to evaluate a Boolean here, which is doing this type coercion, it say, hey, what is the Boolean value of an array? All right, and Boolean values, or truthy or falsy values, has a well-defined list of what is a true or false, right? So for example, anything that is now null, undefined, positive or negative zeros, none, empty string or false is false, and anything else is true. So in this case, this is true, and this will be now flipped between true and false to become false. All right, and the algorithm, all right, this double equality or loosely equality says if one of the operand is the same type, all right, so well, perform now a same type operation. All right, so they are true. However, if, for example, one of them is a string and the other is a number, perform a string operation. In our case, this is not. If one of them is a Boolean, perform now a Boolean operation, which is convert that, which is this. This becomes now this becomes now 1. All right. So convert that into a Boolean operation, all right, which is false. And anytime, this is exactly, this is false. So once you evaluate this becomes false, you say, well, anytime that you evaluate now a Boolean operations, I want you to coerce that into a number. And I didn't lose my mind. Let me actually take a look at that ECMAScript language spec. All right. Let's take a quick look at that. The double equal. Is loosely. Why not? Is loose. Is loosely. Okay, it's a strict. It's a strict. Is, I don't know why it doesn't find them. Well, maybe 1, 2 is comparison strict equality, abstract equality comparison. Here we go. There you go, abstract equality comparison. This XEE is where this, right? This is what is the abstract equality comparison. Oh, it's because this is some version of the, anyway. But you can see is this, if this is a Boolean, all right, I want you to coerce that into a number, bro. So in other words, it going to coerce this into a number, which if you coerce false, what will be? the coercion of false, well, it's give you 0, all right? And then it asks this following. If one of them is now an object, all right, I want you to now coerce that into a primitive. So call the two primitive, which is going to now pass a hint of a string behind the scenes, all right? And it's going to coerce this into a string. So what is the coercion of a string? What is the coercion of a empty array? All right. Well, that this, for your surprise, this is an empty string or an empty value. So if you have now this empty value equal to false, so what is the next step here? All right. Well, if now the algorithm say that which is this is 0, the algorithm say that if you have now a number and the other is a string, all right, I want you to do a numeric coercion in each one of them, all right? So for example, in our case, if this is the number is type and the type is t, I want you to coerce that into a number if that is a string. So this is string coercion, as you can imagine, into a number. What do you think that a number empty a string is? All right. Well, and the coercion of an empty string is exactly 0. So if you say, for example, the coercion of an empty string is 0, so therefore 0 of course is equal to 0, right? But again, the idea of this is that we can able to describe that particular algorithm, all right? So now no longer this is magic. We know what is the predicted outcome of this, and therefore we can be a competent JavaScript developer. So that's good. That was quite interesting to walk through that. I must admit. And then the string value method. So for example, add or the char add. The difference of them is that both of them returns now is the character. No, both of them return is the character at that position that you set, that you pass, which is an index, all right, a number. Add can now go through negative numbers. We also look at the char code add, code point, to actually get now the specific code point or numeric code unit, all right, and that specific string, all right. Then you also have the substring, the splice as a way to see how you can now get a specific sub element or subsection of that sequence of that string, the two uppercase, the two lowercase, to upper local, to local lowercase, okay. Also the concat, the index of, to say, hey, I want you to now find this particular string, okay, and give me is the index of that, if that actually exists in it. If it exists, it's gonna give you now the specific index, all right, which is part of the thing. For example, you do this. So you say, hey, hello world, right? Hello world. You say, hey, char, give me the char at the position 3, right? It's gonna give you the char at that position. But now I want to get is the index of based on this. We have the number 3. No, it's gonna give you now a number. What about, do we have any? Oh, yes, it's in this position, all right. What even you can pass now is a uh, unlike now includes, which gives you a boolean. Exactly. Unlike includes in search, where you can pass now a regular expression here, okay, to say, hey, I want you to is I want you to now tell me is if you can find so all the occurrence of the letter O. Let me see. So it's, mm, I don't know why I'm not able to generate that regex. Jesus fucking Christ. Regular expression, so regex expression. Why not? I'm giving this, alright? I'm giving this. Exactly, it's this one. Oh, it's because let me. Okay, I know where it is. So I'm telling here is that this one. All right. Jesus. Oh, come on. Hello world. Search via regular expression and say, hey, you know what? Please give me is this regular expression that I'm about to do, which is find any O. You know. Find any O globally. Match any. Match any. Okay. Okay. So in this case, we'll need to do something like this. No, it's because it's this. It's because it's this. This is the regular expression, and I can say, hey, find the word O. Okay. Okay, I get it. Okay, so this is how you can do this. You say, hey, I'm doing this is because I'm escaping this character, and do this, right? So now it's gonna give you is all of the occurrence or the first occurrence here, because now it's giving you the first occurrence of the letter O. Okay, but what if I want to get all of them, right? What if I want to get all of them? Okay, I must admit that I don't know how to do this. I have never, ever, not white space. I have never been able to do this. All right, Jesus, why is this so hard? It's because I don't get it. Just like that, it's because I don't get it. It is hard, it's because I don't get it. That's what it is. It is also because perhaps regular expression here. Oh my God, why Jesus? Again, I don't get it, man. Really? Search only find one? Search only finds one? Oh, exactly. Search only finds the first. Okay, it's because I confused. Okay, so these are string methods. My confusion was about the behavior of those string methods. Now, with the alright, makes a lot of sense. Now, we described to add, char add, the difference between them, as well as the code point, code in the uppercase, lowercase, locale uppercase and lowercase, and the how do you call it? How do you put it? The concat, the index of, as a way to get now the index of a particular string. Okay, if that exists. If it's not, well, get out of there. So a good example of this is the hello world. All right, such as the index of. All right, and please give it to me if the O exists, for example. Give me the first one, that's great. All right, the other is the last index of, that search from the last to the beginning. Then we look at the include, the search, and the match. All right, so the include give you now a boolean if it found that, similar to the index of. If it found that particular string, the search, it's going to evaluate now in a regular expression, and it's going to give you now the index of, the number of that. All right, the first occurrence of that. And then we have now the match. Well, with the match, this is my confusion, because the match is say, hey, I want to now pass is this one, bro. And I want to find all of them, right? All of them. This one, but I think it's this. But I want to find all of them, and it's gonna give you now into these collections. So all of the occurrence of that letter now match is going to do that, which is great. All right, which is great. Then we look at trim star, trim end, trim, repeat, pad star, pad end. Useful if you want to now create some sort of behaviors on that. The other is a start with and end with, to check if that actually exists there. The other is a match and match all, as well as replace. Okay, to say, hey, and here replace now allow you a string, and it's gonna replace that with the first occurrence. So for example, like hello world, here we got it. And then we say, hey, replace, bro, replace. So I want you to replace the first occurrence of the word O. Okay, search for the word O and replace that with I, right? However, if you want to now is replace all the occurrence, you now provide a regular expression here. Okay, you provide now a regular expression here where you say, find me, for example, all the, can you, what the, okay, find me all the O's globally and replace that with I, right? Of course, it's this, and it's going to do that for you. I think this basic operation of stuff, all right, the methods of stuff, it's important to understand that and how that works, because anytime that you need to find this specific words or things like that, you know what it's doing behind the scenes. The other is the normalize and local compare, and those and some string helpers, right? The string for from charcode and the string raw. Also the escape characters, how you can escape in characters. So for example, line continuation, this is more like a fun thing that you can do in JavaScript. Multi-character escape, whether it is for the Xcode or Unicode, And in the case of Unicode, how you can now is work with the Unicode string, all right, and why we look at this particular convention of the curly braces, and how it's important to normalize the Unicode, because it will prevent you from some of the other things that I mentioned and behaviors like that, right? Now we have number, and here in the number we got another domain. This is another universe here. But again, it's important for us to understand how now these numeric values are represented, whether it is the whole numbers or the decimal, all right? For example, minus 42 or 3.1415, all right, the P number, and that is using is the IEEE 754 spec, double precision binary point floating of values here. And I know that the name is might be quite long to understand or to even describe that. Yep. It can be a little bit long or to describe that. All right. But the point of this is that by looking is at how these numbers are represented by our machines. In other words, in this transistor or in this capacitor. But the reality here is that most of this memory is now using is solid state, so they're using now transistor to store the state of the data. In other words, is to maintain the electrons there, all right? And those electrons are going to represent is numbers depend of the charge, all right? Which is zeros or one, and because of that, now the way of how we're gonna represent is by saying, hey, this double precision that we're talking is now 2 times 32, 64, where now the first 52 are now is the mantissa, all right? The next 11 bits is the exponent, and we'll have 1 for indicate the sign, right? So as you can imagine here, you can now look if a particular number is an integer or not, okay? Using is the number that is integer, and checking is the parsing and coercion. So parsing is whether it is you want to parse now a string into a whole number or a float into a whole number, or I mean into a string into a decimal, right? There's some nuances in there. So for example, with parsing you cannot support anytime parsing encountering that a string is a dot, it's gonna stop there. It is important to use now is the radix for parse in to prevent any confusion behavior, okay? And the other is a parse float. So parse floats is if that find is a dot, it will continue to evaluate that. It also evaluates now scientific notation, which is quite interesting, quite cool, all right? This is for parsing, and the other is for coercion. And the coercion is the way of how you can transform now that particular value, the particular primitive or object into a numeric value, whether it's a number or a plus operator here. So I think this is quite interesting, quite powerful, quite good, right? Because when we're able to describe this, all right, for example, number, okay, and we can now represent is other type of numbers, whether it's hexadecimal, binary, and octal as well, using also to describe the scientific notation and how can we improve the readability of our, for example, long numbers, right, in segments that are meaningful for us, right? So for example, a million, a billion, right? When we now look at the, even I made a particular demo here. When we look now at the way how these numbers are represented there, and because now we are quite familiar of that, because these numbers can represent since this 52 is the meaningful number, all right, it means that the more so the mantissa is the meaningful number representation, all right, since this number here is now how you can is described as whole numbers or decimal numbers. So the more whole numbers you have, the less space you have for decimal, and vice versa, all right? So why this is important? Why this is important? Because if we want to know now the limits of how much can we represent, all right? So we can now represent here is 1.799, all right, positive number, which is approximately is 2 power, which is the biggest integer that you can represent, all right. This is the biggest integer that you can represent, the biggest number that you can represent, all right. What it is, bro? Why not? For real? You got it. Okay, so since this number, okay, this is the maximum number that we can represent, okay, which is approximately is this, right? 2 power 1024 minus 1, all right. So since this number is huge, and as you can see, this actually is now a biggest integer, all right. So this number here is a number max value. This is the max value that we can, this is the max integer value that we can know. And you may wonder, how do you know that? Well, if we use the integer methods for that, to say, hey, if this is the biggest value, is this value is a whole number? Yes, it is. That's great. So you might wonder like, hey, if I want add or 2 or 3, it seems that I can represent is those numbers. I can even add more number to that, right? Or I can even go beyond to that, and it still gives me that. So IEEE defines the value infinite, all right? as a far end of the number line values that can be test and seized. All right. So we can continue to add those numbers, all right, until we reach finally to the infinite value that we're trying to seek, right? So if we want to now know what is the frontiers of the numbers that we can go, the integer numbers that we can go, all right, we can do that. We're using is infinite, all right, infinite or minus infinite. So for example, we can check that is through the is finite here to say, hey, if this number is finite, no, is infinite. Okay, and you can also check at this number dot max value here is true. All right, which is great. So why we are mentioning this? Because no matter how long your program can run, because of the +1, this is actually incrementally this is actually incrementally the number beyond the max value of that. However, if you, for example, now wants to add numbers close to that range, all right. So for example, max dot value plus I is 219 or 291 or 292, then you reach now this limited, this infinite number. So again, the range of that is this particular number that is something like this. The idea of this, the arithmetic operation of an infinite value will never produce a finite value. All right, and we are actually describing is this realm of numbers, all right, especially of the numbers, how you can parse that, what is the coercion, how is those numbers are represented, other numeric representation of objects, the scientific notation, as well as the readability that we can improve, and how it is important to understand is this IEEE 7054 spec, because now from that we can actually look and understand how these numbers are represented, understand is the limits of those numbers, and how now JavaScript exposes is the limits of those numbers, the max integer number, all right, and anything that goes beyond that, especially if you, for example, sum 1 point plus 1 or plus a million or 10 million, it won't do any difference. But if you now sum some close numbers to that n, all right, if you want us to now add a particular number close to that n, so for example, close to the, all right, close to that n, then you hit now is the true limit of the JavaScript representation of that. So this is also important to know, because here we can know is the max value that we can represent, the mean value, all right, the mean value, that if you ask that this value is now a whole number, must be a whole number that is integer, is integer, all right, it tells us that this is not true. So this number mean value represents now a fraction. This is what is the minimal value that we can represent, all right, here, which is now a fraction, all right. And now how with this we can say, well, actually this is now all that I need to know. But there is another concept called the safe integers. And why this is important, because especially if you're going to perform now mathematical operations here, there is now a limit, or there is now an accurate representation of how you can actually store those numbers. And actually there is a limit to that. So for example, the max safe integer, which is this is the maximum number that we can represent when we are now doing operations among numbers, all right? So because this number is way much lower than we can think of, now there is a particularly nifty detail of the JavaScript language, especially for numbers, and for any IEEE 7054 programming language that follow that spec, which is a ton of that, a huge of that, all right, that has this particular problem, which is when you're trying to represent operations that are not accurate. So for example, in the case of 0.3 or 1 divided 3, when you want to represent is a result of operations that are not accurate, okay, because our memory is limit, the computer chunks that, all right, and then now give you is the closest an approximations of that particular number, all right. This number doesn't end there. This number is huge, my friend. It's huge. So this is why, for example, when we do this 0.1 plus 0.2, and that gives us is something like this, all right. The idea of this is recognize that there's something that exists for any language that implement that, all right. And a way to prevent this, all right, is to say, hey, try to move your numbers, especially if you want to work in JavaScript, try to move those numbers into a whole position. So in other words, instead of doing that, do something like this, all right, move those numbers into a whole position, and then now if you need to, well, divide that to the position of digit that you want to represent. This is one of the reasons why, for example, there are some libraries out there like Decimal GS that allow you to work with decimals, and how now, for example, in Stripe API, what it does is to now move those numbers into a whole number section, and then do the operations, and then now notch the decimal points, all right. I think that's very good way. That's quite interesting, and how they handle that. How, for example, how Stripe handle or any decimal point operation. Yeah, I think that's important, especially if you're going to work in the realm of JavaScript. Integers only amount. Exactly. Exactly. Sense based interest. Invalid integer. Interesting. Very, very interesting how they handle that. Very, very, very interesting how they handle that kind of stuff. Absolutely. So send-based system. So what they do is to transform that operation there, okay, and they now move the decimal to the specific one. Exactly, and they compute that, all right, and then divide that for what they need to. This is a practical implementation of that. The integer-only approach eliminates the precision errors that plague floating point arithmetic, ensuring that every cent counts in financial transaction. This is another reason why, for example, the big int emerged. Because then if you want us to now try to represent its operations that go beyond the quadrillion, all right, and that to me is mind-blowing. Yeah, that to me is mind-blowing. Then you want us to now use this particularly big int operation. Interesting. So they perform that. And this is one of the problems that we have for this. This is one of the problems of the 0.1 and 0.2. And this is something that is plagued with any other IEEE 7054 programming language that use that. All right. So I think that's a very good review of how do we get here. All right. And then now the other values, for example, like positive or negative zeros, when we use this, so for example, when you want to represent is now directions, positions, movement, that kind of stuff, or speed, the is-nen, okay, to represent now a non-valid representation of a number, which at the end of the day is a number, and especially useful, for example, is that how you represent is now mathematical operation that produce is an invalid result. And think about this for a moment, all right? If you now, for example, try to, let's say, add now a string, or let's say a non-number, right? So values like undefined and null, right? If you say, well, let's say your sum is undefined plus 10, all right? Wouldn't be that really an unexpected value if you, for example, output like undefined? That's not what undefined actually means, and not to mention null, all right? So you can also try to, well, do a try catch. So if you want to do an operations, so you will have to do this try catch all for your math. And the other, the only sensible behavior is that numeric mathematical operations should always produce is a number, even if this is not a valid number. So for example, in the case of this is going to produce, which is to me quite interesting, this produces now infinite. And if you say that this is a number, okay, if you want to know the type of the infinity, it makes a lot of sense that that actually is a number. All right. So any operation that is not a valid math result is gonna give you now this nan. So infinity is the same as the infinity, right? That's right. But if you do, for example, not a number, well, this must be the same, right? Well, nan is the only property here, or the only value that is not equal to itself, all right? And there is a reason for that. So those NAND operations, or anything that produces a NAND, it is now a number. It is now a unique number, all right? So for example, it's like trying to put labels on each one of those invalid operations. So for example, like this, what will be so for example like this, like this, all right? So this producing is now a invalid number. The same for this, the same for this, the same for this, and this, and this, and this, and you get it, right? So how do you now is to represent those relationship here? Well, again, the TLDR of this is when you want to check NaN, it is preferred to use is the built-in method from number called is NaN, all right? To actually check if it's a number, is not a number, it's not a valid number, or the other is the object dot is. So to make sure that they are now that these two, not a number, are the same. Okay. So far so good. So far so good. Because now that we look at that, at the number, and how do you represent those numbers, and then the parsing and the coercion, something that we're going to see that, of course, and more in depth later on. The parsing and the coercion, and how when you want to parse, you can use the parse in or parse float, the nuance between each one of them. For example, the parse int with the how do you put it? The parse int for anything related to an integer, right? And the parse flow that allows you to now parse is also scientific expressions. And then we have now is the other way of representing objects like octal, hexadecimal, numeric. How you can now improve the readability of your numbers. That I think that's quite interesting, right? The readability of your numbers. And then now, what is the IEEE 754 spec? How this is organized, and what does it mean? What is the mantissa, the exponent, and the sin? the sign. And when you try to now know if a particular number is is a number, all right, or when you know, or when you now understand the structure of this spec, and then you want to know about the limits of these representations. What is the max value? What is the minimum value? The max value is the whole number that you can represent. And understanding now this will give you is that this mantissa or these representations, the bigger the number or the bigger the whole portion is, the less is for the decimal and vice versa. And why this is important, especially if you want to now understand is the safe integers value, or the mean and max safe integers value. Because especially when you want to do operations, not numeric representations, it's operations, okay? Additions, subtractions, multiplications, exponential. When you want to do this kind of operation, we have now a limit that we can hit to, right? Which is now a 9 quadrillion, which is a 9 followed by 15 digits, all right? You can represent up to 17 digits, but the problem is that any number that go beyond that, so for example like this, say any number that go beyond that number that is max safe integer, all right, any number that goes beyond that, you can add that plus 1, but plus 2, but plus 3, and then plus 4. But as you can see, it's something quite weird here. It's like, what the French toast happened here? Especially when you add with 2. You know, you have the same number. And the problem is that is because the way how now these numbers are represented, that they are not accurate. And by accurate meaning is that how do you represent, for example, 1 divided by 3, all right? Since you have to divide a 0 times 3, 3, 3, 3, and by accurate meaning, I want you to give me now is a complete number here, right? It's pretty much like when you divide 1 divided by 2, 0.5, period. There's no more numbers there. Because of this, that is not accurate, this representation, okay? Well, what is doing the language is to round that number and therefore perform the computation. This is one of the reasons why, for example, 0.1 plus 0.2, it gives you this funny number. And it's because that internal representation. In any programming language that use that IEEE 754, all right, spec is affected by this. So how this, for example, companies in the finance world has solved this issue? Well, for example, Stripe say, hey, you know what? We're not going to deal with any of these floating numbers. It is a nightmare. We prefer to deal with these whole numbers. So anytime that you have this kind of operation with cent, we're going to multiply by with 100, where now the cent is the minimal unit value that we can represent number meaningful, especially in any exchange or trade. So that's what it is, okay. And then we have is this. We say, hey, 0.1 times 100, all right, and I want to round that, right? So math dot round, and I'm gonna round that here for some reason, right? and I'm gonna round that, because if I don't do this, if I don't round that, what happens is that I'm going to continue to have the same French toe issue. You know? So no matter how much decimal do I have, so I eliminate myself an entire series of bugs. And now, this is how, for example, this kind of applications are solving that, right? And I think that's very, 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 very interesting to understand that. All right. We also look at the positive and negative values and when can we use that for movement or speed. The other is the invalid number, which represents now is the. I will ask you a question. How do you mathematically represent an operation that is not valid? We can argue that we can say, hey, let's go with null or undefined, but that will be weird, because null, what does it mean null? Exactly. You declare that value, but doesn't have any value there. You declare that variable, but that doesn't have any value there. All right. What about undefined? Well, is that we don't even declare that. But the problem is that is declared. It's not valid. So the other is that, well, try and catch all of this math operation that we want to. And it's more, according to also Kyle Simpson, so it makes a lot of sense to now define is the nan as a type of number, and any time a mathematical operations give you a numeric operation, okay? So anytime a mathematical operation returns you an invalid number, well, it is important for us to describe that as a number, all right? And now numbers here, so not only that, so for example, if you do something like this, all right, this is not a valid number, or this, all right, this is another not valid number. Again, this and this are quite different. Why is that? Because there are two different mathematical results in this example here. But the thing here is that I don't want to bore you to death into this. I just want to know that nan is a value here. So nan here is something that is not unique to itself. So you have to be careful, especially when dealing with this type of value. And the way to check that is whether it's by using is a number that is nan, all right, property, or the other is the number, the object dot is, right? You can pass now here to nan, and then now the algorithm behind the scene is going to say, okay, yeah, now you're telling me that semantically they are the same. So I think that's quite interesting. The other are the number behaviors that we're starting to look at this. Floating point imprecision is something that is worthwhile. I don't want to go into that. The other is the epsilon imprecision. And let's go into this, my friends. Definitely, bro. Definitely. The number behaviors. That's right. Here we go. Yes, we mentioned here. We can also try to look at this. Mm. Mm-hmm. Yeah, the epsilon threshold. Mm-hmm. The numeric comparison, the mathematical operators, increment and decrement, bitwise operators. Mm-hmm. Just compute new values here. A number values method. Okay. Let's go. Let's go. I think this part to me is quite boring, but let's go. Why is this might be boring? All right. Creating floating point error drift. Okay. Yeah, creating point floating error drift. So epsilon threshold. A common piece of advice to work around, such as floating point imprecision. Use this very small number. You know what? You know what? Uh, okay. Floating point imprecision. Hey, Claw, help us here. Mhm. Floating point imprecision. I prefer this. Floating point imprecision. The binary representation. Okay, I think this is quite beautiful. I think this is quite beautiful. All right, to show and illustrate that what's going on, and what are the code that is using that. It's using a lot of functions instead of class, which is okay. Demonstrate the classic program. It uses a lot of the get element by ID. Okay. Get element by ID, and instead of using the selector for that, which to me is my banding. Yeah, which to me is my banding. And the start animation. Query selector with a header in each one. All right, good. The floating point precision. Understanding why 0.1 in this. I think that particular piece of code is quite interesting. There's also some solutions or workaround. One of them using epsilon. I don't recommend use epsilon for that. I'm gonna read about that, but we prefer to go with the round because now epsilon's what it means is the smallest number between 1 and the subsequent and the next to it. All right, so it's preferably to use now is this, right? For example, math round, so you actually can be sure that that will work as expected. The other is using a tolerance value as well. What will be the tolerance value that you can go with? Okay. Solutions and workaround. In solutions and workaround. So except to provide a readable format by breaking in words anytime a class calculation in an element is in use. Yeah, because it's breaking that. Exactly, way much better. Way much freaking better. Oh my god. That's a lot. Perfect precision, no rounding errors. Exactly. I think that'll be great for them. Yeah, absolutely. Okay. And the other is now and the other is now how do I put it? Floating point imprecision. Floating point imprecision. Here we make is this. We add a new file. That's it. Called index.html. And there you got it. Floating point. Let me now mount that because I want to mount this in Vercel. I don't want you to watch this. I'm sorry. Versa. A new project. Floating point imperfection. Okay. Bueno. Authentication goes. Yeah, and after that, we're gonna close this. I'm going to close this. There you go. Ding. There you go. Holy fuck. Oh my god, that was blazing faster. No build tools. No, none of that. None of that. None of that. None of French does that. None of French does that, bro. That uses, or that, yeah, that follow, or that implement IEEE 7054 binary double precision binary point floating numbers. Okay. Or how and some solutions. Exactly. And how the industry solved it. That's right. There you got it. And if we go to this, yes. Mm. So that'll be all for this video. Take care. Bye bye.